All right. Pause recording. How about pause again?
But
This meeting is being recorded.
All right, let's do this part. So everyone's being recorded. You show up on YouTube in a couple hours. We're here to talk about compilers, which includes people's hacks of IDEs and or build systems, which really lit up on the Discord channel big time. So why don't we take people who got stuff ready to go now, to be Levo and IDE, and I will talk to Allan and see that his demo or his talk is like ready to go, because a half-baked talk is only half-baked. We'll look at it. I'm curious to see what you got going there, Allan. And then we can go hit,
there's one tiny change I want to make, so I might be ready in like 15 minutes.
Oh, you're hacking code still.
I had enough time for a bonus feature, so I'm gonna go for it.
You're gonna go bonus feature land. All right, well then we're gonna go builds. Oh, here's another person coming in here. Derek, where are you? Okay, without Cameron here and trusting that we'll sort this out, and we'll do it live. Yes, we can watch Levo code live. That could be entertaining, and it could be, I don't know. I mean, watching somebody code live seems less entertaining than watch somebody play, Breath of the Wild live or something. Just like Twitch stream gaming, Twitch. So we talked about build systems.
Can go on Twitch and just code live all they want.
Exactly.
They don't need.
I'm not going to be watching that. So
to do that.
I think people would find me very boring while coding live. Maybe not. Maybe people all get excited about it. I don't understand. I am not going to be excited to watch somebody else code live.
I don't know. I think I would take the code live over Breath of the Wild.
Oh, I see. I picked the wrong game then.
Maybe.
But what game would you like to watch live?
To be honest, I don't understand all these let's plays. So
you don't have the gamer mentality.
Yeah, well, I do, but I prefer to just play them myself.
Do it and not actually watch somebody do it.
Right.
Yes, occasionally I have games. I watch Potato McWhiskey do Civ 6 because I can't beat a deity mode Civ 6 game, and he does sort of casually, and it's kind of fun. Like, what the hell are you doing, and why are you doing this or that? Oh, this is the right time for blah 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 blah. And why is it the right time now? What the hell? So I enjoy watching somebody who's highly skilled showing their skills. Fine.
Well, if you've got a good if you've got a good whisper, and then you could do an ASMR type of live coding thing, that might work.
I need more coffee for this.
And now we close the parentheses so that they will be balanced.
Wow, you got it.
Has anyone watched Steve Moll do his science videos? He's got this calming voice and these blue eyes, and he's just kind of, I won't say seductive, but very, I don't know, there's a thing to watching him do his videos. It's like, okay. And then he does something smart and clever and intelligent, and you have to stare at what the hell's going on. And he pulls the camera angles out, and you're looking at this thing happening, and you're like, that is fucked up. What the hell?
I'm curious how the contrast would go between someone fighting with C++ templates while doing so in that calm.
Well, when they pull the hammer
out,
look,
it appears it has dumped 75 megabytes worth of error. Let's switch over to awk and see if we can figure out what's gone wrong here.
There is a contest for the shortest program with the most lines of error, and C++ wins by a large margin. Fine. What was I going to say?
It's actually hard to get Python to give you a really long error.
Oh, yeah. Well, I would assume almost anybody could do something reasonable here. There's some short one-liner syntax error in C++ that invokes recursive templates on itself. And suddenly it explodes out to 100,000 lines.
Define public to private and then include some standard header. And it just does not like that. It does not like that.
Fine. Yes. Oh my God. There's so many errors now. That's true. Fine. So we were talking on Discord.
I used to see that in Python puzzlers, where people would redefine false as the empty list.
Yeah.
And just see which things do and don't work if you've got the empty list instead of false in Python. It makes some good Python puzzlers.
I've done this in R, where you can define true as false or something else, or hello world or something. And yes, of course, System chokes. All right, fourth time I will attempt to say make systems. For no good reason. Cameron and I lit off on each other, which is very unexpected. And I was hoping he'd be here, but he'll be here in a minute, I'm sure. Anyhow, it turned out that we had these classic miscommunication. And we were talking, somebody was talking about bemoaning build systems is pretty common. And somebody was complaining about how much or how fast or how little or whatever. And I was pointing out that you can just track all your dependencies and do a timestamp super cheap and you know, it's all good. And he was like, no, it fails because you delete a file and the file's not there, you don't get a timestamp. And I was like, file's not there counts as missing file, needs to go build, right? And the miscommunication was, he was thinking, no, you delete a required input file and you don't get a build error because the input file in a dynamic dependency sense isn't available. If you have a build system where you have listed all your input dependencies specifically, and you delete one, the build system catches it and says, hey, you don't have it. But if you have a dependency that, like, you're in a C++ land and a C land, whatever, and you delete a .h file, but you haven't listed the .h files on your dependencies for every C file, which is a pain in the butt to keep up because .h files come and go in my C files, then it's just a missing .h, but no one had a reason to recompile. So no one notices it's missing. So you can't actually build your final artifact because your C doesn't have a .h, but the C didn't change and the .h wasn't listed on the dependencies. So the fix that I came up with long ago, and I'm certain I was never the first on this, was I simply took all the .h's that came out of a C file, which you discovered by asking GCC with a -f flag, and you put them off to the side. That's your dependencies for this C file. If that file is missing, you have to build. If that file's list of files, they're all dependencies. If any of them are missing or timestamped wrong, you have to build. And after you build the C program, you know, recompile C, you re-get a new, you know, .f file with the list of .h's inside of it. And that was apparently news to him. And and that was, you know, that was the root cause of the confusion. Anyhow,
so to me, this falls into a preferred defaults to configuration. One of the things that caused a mess in C was the C compiler didn't know how to find anything, so you had to pass in everything that it wanted to join. And it's a lot more convenient if you have a language where I can just say make main.language, and it looks at the import and goes, ah, because of the structure of this import, I can tell where on the file system I should look to find the thing.
Well, are you talking about, I'm sorry, you're talking about make understanding how to build a .o from a .c? Or are you talking
about... The point is that you need a .make because GCC doesn't know where to find the code.
I see.
If I'm in Python, I don't need a Python make file. I say Python, I call main, and main's got imports. And because we have not configuration, but defaults that say these are the places that I will look to find this thing, and I will look in this order. And
Python got that piece right. No, I was complaining or talking about make files. Oh, somebody asked me about things I wanted about make files or did or didn't want about make files. Not make, build systems. So be careful. There's nothing with make. So I have a short take for this. One of them is make syntax sucks. I admit it. I like other things about make than the syntax. I deal with the syntax. It sucks. Ignore it. Carry on. I've seen build systems, not to mention Gradle, cough, cough, that didn't use file timestamps as their primary reason or thinking about what this is ahead of that on. That in turn led to me having Gradle fail to build about once a week at H2O. So nice big project, big company, a lot of people doing stuff. Not big company, I'm sorry, you know, 20 engineers, whatever. About once a week, I think twice a week, Gradle would fail to build a thing that I had just edited, the resulting artifact. I would then run the debugger using the old stuff because I didn't notice it didn't build. And I would spend a good hour trying to diagnose my race condition, which was only probabilistic anyhow, before I realized it just wasn't happening or just wasn't fixed. It should have been fixed, and why not? And then I'd go back through and do a little more check and a little more check and suddenly discover that I think it never got built. So then I go check the actual artifact that should have been built, see that it didn't get built, do a Gradle clean, Gradle build. Oh, I fixed the bug. fuck, there's a half a day lost because Gradle failed to build. Why did Gradle fail to build reliably? You know, once a week I claim is pretty reliable. Why is it that an issue? Like, I see somebody else, right? Shaw says that Gradle's not figuring out. What the hell? Why not? It's like fucking timestamps. It's instant. It's quick. It's easy. It's obvious. Timestamps are like atomically updated by the file system. You cannot fuck them up in a multi-threaded environment. So I can totally run parallel make all the time because timestamps work. Fine. Okay, so that piece was a hate on people who didn't use timestamps. Then I had ones where people liked build tools that spewed noise. Hi, this is version 123 of Macrosoft's .aki thing or whatever the fuck. And after you get a few hundreds of those going by, your error messages get lost in the drowning sea of here's the spewage of everything that works, except when the one piece that didn't. And it goes, and it's done at the bottom, and it says build failed. And of course, 10,000 lines back, maybe you can find where it failed or not. So I have a hot take, and I did a couple manual build systems myself with this, and it worked great, which is if you output anything on a successful build, it's a fail immediately. That build step fails. Your tool claims success and it printed, the build step failed. Now fix your build step so the tool doesn't get to put anything out. The easy one is the tool gets redirected to standard out to some temp file. On a success, you blow away the temp file and keep moving on. On a fail, all output is fair game. I don't care what your output, it's all good. But on success, output, nothing.
What about warnings?
Nothing. If you have agreed that warnings are not errors, then they're not errors and they're not really warnings. If at my desk, I want to convert warnings to things I'm going to be actionable on, then I'll ask for them at that time. But if I have a large build system with 20 or 100 people going and warnings are enabled, they just spew, but they're not an error, so no one cares. So they just choke up the log file, the output, no one knows, no one cares. So in my opinion, warnings are sort of a mistake. You should
Yeah, I
either
think that is
fail
the
or
important
not.
thing, right? If it's a warning and you have millions of those, nobody will care. And people
Right.
stop caring.
Right. And then Charlie's saying the same thing. Warnings are errors or warnings are silent, but they're not actually warnings. There's nothing to them, right? And that's fine. So
I mean, I think there's value in outputting info, but dump it to a file.
no, dump it to a file. And then on a successful build, I will normally nuke it silently behind your back because I don't care for it because it was successful. Right. This is if it worked, why are you telling me something other than your final build artifact worked? So I don't mind a verbose flag that says 1 line per file as the thing, as the metric of progress in the build system, 1 line per file made. I don't mind a more verbose where all these outputs are welcome. You say -VV spew, I don't care, it's all great. But if I just do make go, I don't want to see anything other than success. And my target of my make tells me what got built. So there was that one. I had them in Discord. I had a bunch. And let's see if I can go pull up the list again without wasting everyone's time here. As we're on to people trying to do typing systems, which have all its own grief, and I can't find my stuff. What was the other hot one? Allan, you asked, what was the things that I was? Oh, here's Cameron and I going to town. Quiet by default. Parallel makes easy. Oh, ignore the syntax. And then I admit that makes helpers for certain kind of oddball cases. There's a bunch of cases like there's Allan Computer. A bunch of cases like in compilers, especially where I run, Allan gave the Bison example, but any compiler step where I input the compiler source to a tool that produces itself code, which I then have to build with. If I edit the compiler to change a comment and I run it, it produces identical output that it had before. And then I don't need to run the next build steps afterwards. So I kind of want a diff between the output of this step.
But the timestamp changed.
Yeah, the timestamp changed, but the content didn't change. Right. And this is an easy hack to work around in a make system where you do a temp file in the middle and a comp step and whatever. You do a little shell scripting and it's easy. Make should have this as a built-in tool. It doesn't. It happens enough in compiler. I don't know if it happens in other people's things. It probably does. If you're running some kind of funny internal format for a language that spews out your GUI, does your layout, and you go into the source to the layout generator and you edit some comments and you change some minor things that don't actually affect the layout at all, but you're just trying to restructure it, and you run the tool and it spews an identical layout and that's expected, you can check that and say, I don't have to go to the next step where I rebuild my entire app on my phone because the layout didn't actually change. Nothing's there. I just hack the comments, whatever. So there's a thing there where you can make that happen. Makes don't have it by default. It would be a nice tool if they did. Whenever I do my hand roll builds, I always throw one of those in, fine. And then the other hand roll build thing, of course, is you get a better syntax. You're using C or Java to go write your build system, and you get to have a more polite referencing scheme. So, all right, I'm done on my take on makes or build systems. I know you had, Allan, it's your presentation about build systems, right?
You didn't touch dependency resolution in your build system.
Oh, no, it's file left, file right with all kind of shortcuts. There's 1,000 shortcuts. This depends on that. I'm listing in the rules explicitly, except there is a, if your name .o, I expect a .c, and I'll just automatically do that unless you override it. And you can say, I have a wildcard of this directory or this directory tree, and all these things that say .java all map to those things over there that say .class at the end with name for name going across the line. Those are all shortcuts you just throw in somewhere. But it's file to file. Ultimately, at the actual build step, it's file to file. These set of files have timestamps that are ahead of these set of files. And then if fails, you run the build step. Where did this set of files come? Where did that set of files come? Well, I named them one by one, or I wildcarded them in various ways, or I have default rules or whatever. There's a lot of ways to make that convenient, but that's the resolution is files on disk, where the OS gives me an atomic timestamp update that doesn't fail and does all the right stupid things. Or I guess another rule I would have just came to was, if a build step fails, all my outputs I'm going to nuke. If I have if you hit Control C in the middle of a long, big compile and it has a half written .o file, it's a half written .o file. I don't want it. So the build step failed when you hit Control C. I'm going to nuke the output of the build step. So in that sense, build steps become atomic, all at once or not at all. They're a transaction on the file system. I see Shaw looking confused.
I mean, like modern file systems, right? They have the ability to like see what, or not file system, operating system. Sorry, they have the ability to like run this process and tell me all the files it touched. Like run this process and like call this thing every time it like does anything to a file, even reads it. So like you could just have this automatic, like call like your compiler and then like say, hey, you know, I edited, I used these files, I read these files. Those files, if they get changed, that's the baseline.
Is there I'm aware that this can happen, but is there a sort of a convenient programming interface where I can go just get the files that are touched?
There's iNotify.
Yeah, iNotify would be it on Linux.
But
And
the thing
is there a
I-
similar behavior on Windows and Mac? That would be one of the rules or goals of like make is that he's the same everywhere. He's same stupid everywhere.
There is something on Windows. Don't remember the name from the top of my head.
Yeah, I'm
there's something
there is.
on Mac.
I know there's something on each. I just it's different each way.
Well, that goes down to
wrap
the dynamic dependency route of, I still need to know that I made a .class from a .java or .o from .c, but everything else that went along with them, I can just pick up by asking the file system, what did he touch? Oh, next time, if he touches those, if those change or whatever, I'm gonna go again. Yeah.
And this persists over like people usually don't like say like, hey, did Studio change? But like you updated GCC. Maybe GCC just updated. Maybe like the standard IO library has a new function that your if defs need to check for. If you're C or like other things, and like people just don't account for this.
Guys always check the tools as part of their things, and they check themselves too. Step one, did my build system itself change? Okay, build myself again, and then invoke myself on the new build every time.
Yeah, but like a lot of people miss this step.
Okay. So like you hack the make file, you should rebuild everything that depends on the make file.
I'm always pretty impressed with Ccache, how good it is at detecting all that kind of changes.
Sure. Well, I wonder if they're doing the same thing you're just talking about with some sort of file watch.
By the way,
That makes
like
a lot of sense to me.
iNotify has also, I mean, like that. I think like when talking about build systems, I also sometimes mentioned like the problem that you get into when you start building on a big, like a large monorepo, because something like iNotify doesn't work on like when you have a huge distributed virtual file system.
Distributed, yeah.
And,
Okay.
and then yeah, I mean there are like these file watching services that you can deploy, and yeah, and some build systems like I know that Bug2, like the thing Meta uses, that integrates with their own like file watching service, and they have like some cool features there. And yeah, like for them, Make wouldn't work in this way because like they have this build system and integrates with this scalable file watching,
Right.
and then yeah, then they have this big distributed file system. So it kind of like the things start to change when you go into this monorepo universe.
So in the case of Make, he never looks at file watching. He doesn't use file watching. For when I'm doing gcc.header files, .c.h.header files, I'm using a special feature of that particular build step. It's C code. I can ask GCC, give me your dependencies, which doesn't obviously scale to other kinds of build steps. So if I wanted to, so it just says it's like two different solutions here. If you're of a scale that you can use an iWatch, there's a solution. If you're of a build step flavor that has a way to list all the dependencies, there's that solution. There's always the static list solution. And then if you're both too big and can't do iWatch or can't use a GCC-F flag, I don't know, you might have to go to the static route and list your dependencies or something. That's interesting. So they went ahead and built a a large distributed file watching service for the build step. That's kind of cool.
Yeah, so yeah, the thing is like this file watching system can also trigger rebuilds of some kind of assets or something.
Yeah.
That just yeah.
Well, presumably you said make, and someone said, well, I changed my JSON configuration file and somebody depended on it, so I'm going again.
Our company policy is now to use the newer version of this thing. So you better watch our company policy file on this server over here. Otherwise it'll...
Right. We bumped the security protocol version number X or the click-through whatever licensing.
Yeah.
And the pop-up click-through licensing add page had to get updated, blah, 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 because some lawyer wrote a file. So I clicked through one of those just last night, very obnoxiously. All right, anything else about build systems?
Well, I was thinking I could run through my presentation.
You still want to do it? All right, Levo, you got a few more minutes. Allan's pushing it. We're gonna let him go. Do it. Fire.
Sure. Yeah.
Allan computer share permission.
Try again. Try again now.
All right. Let's see. Working? Oh no, my computer just froze. Oh well.
You should rewrite it in Strauss-Code.
Yeah. Let's see. So yeah. I think I want. All right.
Oh, something's trying to share.
Has started sharing screen, but hasn't started sharing.
No,
Build
I got it now.
systems.
Okay, good. So yeah, okay. So the first thing I should mention is I made this huge list of build systems.
Oh, so this is a partial list of build systems, right?
Well, this is the list of every build system that was added to Wikipedia.
Okay, fine.
So like,
let's pretend that we can't read this and move on at some point.
Oof.
Yeah, so the Wikipedia people, they have this habit of deleting everything that doesn't have a source or that's unreliable or doesn't, isn't sufficiently notable. And so like it turns out like most of them, they become notable later. They just, never, and then most of them never do.
Well, all the notable ones had a start where they were not notable.
Yes.
So but that doesn't help. It's same as the stock market, IBM became notable at some point, but most people who start die and a few become notable.
Yeah, so these are the ones that I've actually looked at in a little bit of detail. So I mean, if you see a build system that's really interesting that I should look at, then now's your time to say, oh,
now's your time. All right, roll on.
I saw someone posted the mill build system.
Oh, the mill?
Yeah, there was like a link in the chat.
Okay, I looked at the hardware. I talked to the dude quite a while. It's been fun. Oh, Go Build. Yeah, Go Build probably should make your list at some point. Okay, so there's general build systems and build systems for like closed universes. Like, I kind of feel like Cargo and Rust belong somewhere, but one's more general purpose. Like Make is never expected to be, I'm just for Rust or just for C.
Yeah. So I mean, that is sort of one of the things that all of these have in common, is that besides maybe Ant and Maven, they're all general purpose build systems.
Yeah. So. All right, roll on. Pants is the ants for Python. That's a.
So this is Make.
Yeah. Syntax sucks, but fine.
Dependencies, you get this dependency graph. Everyone knows how Make works, right? So this is Ant. It turns out it's about the same. It's just like XML.
It's just XML, and talk about syntax hating.
Yeah, the interesting thing is there's this up-to-date rule, which Make doesn't have, and so it turns out you can disable build rules like on the fly, and so that's where like all your stuff about like Gradle not building well comes in, is because if the disabling, is the wrong logic, then the build is broken and it doesn't.
What does up-to-date do?
So it sets the property to true if the target file is more up to date than any of the source files. So.
Oh, it answers the question that Make asks.
Right, and so you have this sort of meta rule in this Ant system. And
I see.
That's what ends up screwing up most of the stuff, is that you have this up-to-date rule, and it just doesn't make any sense in the context of like a build graph.
I saw XML, when Ant first came out, and was like, well, there's a fail, and never looked back.
And so the Maven is sort of, it's like a package manager. You have these dependencies, you specify each dependency, and it basically assumes that a dependency is a jar file. And so that's.
By the way, you can do this in Make in 1 or 2 lines. This is like nothing special here.
Yeah, and then there's Gradle, and it's basically Maven and Ant. It's not it's interesting, but it's not like, anything new. So then there's Basil. I had to look up how to pronounce it.
Notably with Ant, you can give it URLs in addition to files, which Make tends to get cranky if you give it a URL.
Yes. So I get that there's the remote build stuff with interacting with build repositories.
Okay.
So
yeah.
It's sort of the extension of this is you have a global identifier for each dependency, and then it uses distributed builds, and so you can download dependencies from a cloud, and then to make it work, they assume this thing called permitticity, which is that if you have the same inputs, you get the same output. And it turns out
the same input hash.
Yeah, so like you assume that for the same, if all the files have the same input hashes, then the output file has the same hash. And that's not true, because you get build stamps and non-reproducible builds and stuff, but like apparently they've hacked it enough that it works for the most part. So
okay.
And the dependency model is still basically just Make. You have a static graph.
Right.
So Buck, I don't know. When I was looking at build systems, I looked at Book 1, but I guess everyone is using Book 2 now. And so they say they have this list of like projects it's based on. The interesting ones, in my opinion, are Shake and Cup, but it's not really that much of an advance over Shake and Cup. It's just sort of, there's the file system watch, I guess. That's really the new part. And then there's this graph. So that link goes to a paper, which is kind of interesting. It's not really I mean, the dynamic dependencies mean that the build graph is dynamic, and so you can add nodes to the graph while you're building.
This is what I do with make when I was grabbing the GCC-F.
Yeah, and so I think Ninja is actually, it's easier to understand how dynamic dependencies work. So here's like the first rule. So this
it has make syntax? No, it doesn't have make syntax.
Yeah, this is Ninja syntax. So it's designed to be generated by automated tools. So it's very easy to parse, and it's hard to write because it's very verbose.
Gotcha.
For these examples, it's short enough to read. So what the idea is that for compiling a file, so the command, you generate the make dependencies while you're compiling.
Yeah.
You also generate the output file. And then you specify that the dependencies were generated in this output file, this output file.
Yes.
And so then when it reruns the build, it checks the dependencies in that GCC generated file and will rebuild if any of them change. And so that's how you get transitive dependencies, perfect transitive dependencies with C and C++ header file.
Yeah, I've done this with make. It's all great. Fine.
Right. And so the main thing is that it's very neat because you just specify the dependency file and you specify that it generates it. And whereas make, you have to deal with some sort of phase.
I have to screw around and make. It's true, but it's not too bad. But you're correct. There's a screw around.
Yeah. So
this is the tooling to make it obvious.
So the next thing they have is this thing called dynamic dependencies. And so here the idea is that it's not enough to just run it as part of the command. You have to run it an fscan beforehand on the source files.
What does fscan do?
So fscan looks through. It's basically it produces the list of dependent files. So it's like it's just the same command as GCC output the dependencies to the make file, except this is Fortran output dependencies as a file, and you can't do it at the same command.
Oh, I see. Okay, yeah, I was not doing the same command either. Probably as part of my screwing around. This was for Fortran, so fscan is like a Fortran. Give me your list of includes.
Right, and the other thing is that you have to scan all the files at once. Like you scan foo and bump at the same time, and so it computes the global dependency graph, not just.
But fscan is specific to Fortran.
Right.
Gotcha.
Right. So I mean, the Fortran is
right because Fortran allows cyclic dependencies between files.
Yeah.
Yeah. No, I was thinking, what's the generic solution for a random build step to discover what files it touches? I thought fscan was some hack to make that work. Now I understand fscan is specific to Fortran, whereas the file watcher technology would be one that would be generic to any build step.
Right.
Okay. And the fscan and GCC-flag are going to work on a distributed file system, whereas a file watcher maybe doesn't work on a distributed file system.
Well, so Facebook's file watcher, they've hacked it, so like it interfaces with their implementation of their distributed file system.
I'm trying to say, by default, out of the box, file watcher doesn't work on a clustered or distributed setup. Facebook has hacked one in. That's a great thing for them to do.
Yeah.
Okay.
I'm not sure if it's public. I know the file system watcher is public, but I'm not sure that I'm not sure their distributed file system is public. So, so this one they use dynamic dependencies instead of static dependencies. And so they have this weird thing where there's an order-only dependency to make sure that the dependencies are generated.
Yeah.
And then they pick the dependencies, and then they build the file. And so then so the Fortran is kind of hard to understand because nobody really uses Fortran anymore.
Well, I didn't understand that the F's here were Fortran. As soon as you said Fortran, I retranslated F95 to Fortran 95, and Fortran F90 and all this, and I was like, okay, fine, I got it.
Issue with the Fortran, I believe, is the module files. So as an artifact of compiling a Fortran program, you also obtain an output file, which is called a module file, which is a dependency to the dependencies that depend on that module because they use the module. But because it's only generated dynamically, you have to use this dynamic dependency rule. fscan is just an example. It's not something that really exists. It's just a hypothetical comment that you would use if you had a scanner for Fortran dependencies. This may come up with C++ modules, by the way. So
yeah. So then this last example, I guess it does actually happen, is you're untarring a file and you want to depend on all the files generated by that tar file, so that if the tar changes and then a file extracted by the tar changes, then you change. But if the tar changes and none of the files change, you don't rebuild.
I'm sorry, the untar says, given a fixed tar file, I'm going to output the pile of things. Are you saying I need to re-untar if the things that went into the tar file?
Okay, well, you have to read it from the bottom. So
okay, maybe that's my mistake.
So you're building a foo.tar.stamp, okay, and the dependency is that it untars the file and that it has dynamic dependencies on all the files. And similarly, building the dependencies, you use this tar command that lists all the files in the tar.
Right, I have a dynamic dependencies. I'm trying to build a tar file. To build a tar file, I need to have all my inputs up to date, and I don't know what they are unless I ask the tar file that already existed what they are.
Right, and then and so the untar itself is just extracting it.
I guess I'm asking, what goes into the tar file if the tar file doesn't exist? Fresh, clean build, what's the inputs to the tar file?
Well, the tar file is something you download usually, so it's just sitting in the input.
So I would have said, as soon as I downloaded it, the timestamp changed. I'm done. It's time to untar it. Like how I do this in Make is I say, I download you. I have a cached copy. I compare them. They diff. Oh, time to unpack the tar. I compare them. They're the same. Done.
Right, and that's sort of where you get this, these up-to-date rules. Is that you're encoding what should be build system logic of checking if a target is up to date into the actual rules.
I think the difference is with that, you would actually get a rebuild for certain files if you change them after untarring for whatever reason, trying to figure out a bug or something.
If I untarred them and I edit them.
And you added one of the untarred files because you're trying to find a bug or anything.
Right. That happens. Right? I get it.
Yeah.
Right.
So
but I don't want to untar again because it'll wipe out my changes. Oh, yes. But you're screwed. No. This is like you have a dependent file. You can't be editing it. Jeez. Ignore me for a second. I'm going to mute myself.
All right. So going back, I don't know. I wish Cliff was paying attention, but I was going to say that like the command output.
I'm going to have to pay attention. I claim it's time to move on from the slide, though.
Okay. Well, I was going to say the command output buffering is sort of what Cliff was complaining about with that it scrolls off, is because it's buffered. You can just replay the output from a command, and so then it makes it easier to debug the failures. Okay. So this is like the simplest build system in theory. Like it looks like this is a complicated algorithm, but that's essentially how you do a build.
What's this called? Redo? Oh.
This is called redo, yeah. And so you just run, this is literally a bash script. So you just run this redo if change command on your input files, and then you run your build commands, and then that's it. Basically, you just run, you specify your dependencies and you specify your output files. And you can see that how it works. It just sort of walks through the dependencies and it checks if they're up to date and if they're not up to date.
And it's using a hash.
Yeah. And it's using, so I didn't really get into this in these slides, but there are like multiple ways to determine if a file has quote unquote changed. You can check the hash, you can check the modification time, you can get a file system watcher, you can check. I mean, I don't know. I mean, there's multiple ways. So Shake in particular, he implemented like, I want to say like 6 different ways. There's like a command line option. So like there's file time and hash, there's file time or hash, there's file time only, there's hash only, there's, it's like, I mean, you can read the command line arguments. There's like a list of all of them. But the main feature of Sake is these dynamic dependencies. And this is implemented a little differently from Ninja, I'd say, in probably an easier to understand way. Is you have, so instead of extracting a tar, this is compressing a tar. So you have a list of all the files you want to go in the tar. You read the files. You depend on each of the files that you've read from the file, and then you tar them up. And so then if the list of files changes or any of the files changes, then it will be rebuilt.
Like the need step adds a new dependency.
Right.
So the do action actually has to start just every time. The first thing that do step does, he doesn't have a right-hand side list of files to check. He begins executing. The first thing he does a need list. Oh, that's the first thing I need to do. If that fails, if that succeeds, I'm done. I don't have to go any further. Like that first need is what I would have done in make as the right-hand side. I need list.txt. If that doesn't exist, I'm screwed. If that, I need to go build. If that does exist, then I guess you have to go to the next step and say, okay, all these deps are now part of it, and then need them as well. But if they're all up to date, you don't do the system call to tar.
Right. And so the way it works is it records a trace. So like this list.txt file, and then all the files in that list are stored in the trace in this build graph.
Okay.
And then when it's rebuilding, it doesn't immediately re-execute this whole rule. At first it checks the trace and that all the files match in the trace, and then it skips the rule.
I see. Okay. Yeah, I mean, in the land of GCC-F, what you just said was a trace would be, that's the list of things that I got out of GCC-F that I need to make part of my dependencies somehow, and then check them.
Right, and so this is sort of putting more stuff in the build system database instead of, having it
right.
File system.
Right, and in my case, my build system database was like his list.txt. It was explicit per build step. I had some place I had to store that list, and it was per file was cited in a .d or whatever. I think it was a .d.
Yeah, and so on the right, I have like, these are the list of advantages he lists in his paper, Shake Building. So there's minimal rebuilds, which is that if you don't change anything, it doesn't rebuild. There's parallel build. I guess, everyone wants parallel.
Everyone does minimal and parallel. That's all the same. Mostly unchanging results. That's all the same. So the syntax is Haskell. It's actually much nicer than make syntax.
Yeah. So the unchanging results, not everyone does though. So like what that is that's if you change a file to something and then you change it back, it checks the hash and it says the hash is the same. So therefore I won't continue rebuilding. And so a lot of systems that just check file modification times will keep building because you can't tell if the file modification time.
Yeah, that's fair.
File.
That's fair.
Yeah. All right. So then there's Tup. So this was a guy who worked on Firefox and was annoyed at slow Firefox builds.
Everybody who ever did a build system on their own always was annoyed at whatever slow build and whatever project they were working on.
So he wrote this paper. It's like build system algorithms or something. So I mean, it's a long and kind of confused paper, and he makes like several different distinctions that all turn out to be the same thing. So like he calls make an alpha build system and up a beta build system, and then like there's never any examples of alpha or beta build systems besides these two. So yeah, but anyway, so the idea is that make has this global DAG, and every time you run it, it checks all the files and loads the entire build graph. And so that takes time linear in the number of files in the project.
Yeah. The issue, of course, is that for 10,000 files, it's still a really tiny constant if you've done any care at all. I see on his chart to the bottom is those times are not the kind of times I was getting for a 10,000 file system to just check the 10,000 files. Like I had an empty build going on, or I was going to build one file. I had to check 10,000 files, and Make was going to check them all. That would be 1 second, not 10 seconds. It's definitely linear in the size of the build graph, but it was pretty quick. Now, if you were going to do 1 million files, yeah, it'd start to add up, and you'd care to do something different. Fine.
Yeah, there's like an actual benchmark on his webpage somewhere. It's like Cup versus Morador versus Make, and that's if it. So Morador is if it was omniscient and knew exactly which files to rebuild in what order and didn't say anything.
Right.
And I think it mostly supports this graph. I didn't look at it.
I'm just thinking his timestamp, his time for file counts look large to me by 10-fold. The shape of the graph is probably correct. He's saying constant for him and linear in size, and it's a log graph, so linear in size has that shape. But
yeah,
divide by 10.
And so yeah, so the idea is you start with all the files that change, and then you look up what depends on, and you set up the index so you can easily figure out, if a file changes, what do I need to rebuild? And so that's why the arrows go up instead of down, is because the index goes from the files to the tasks that depend on them.
Sure. All right, Cameron, I took your name in vain earlier. You'll have to watch the video to see what I said about you.
I don't know. Whatever you said, it's probably worse. I'm probably worse than what you said.
Well, I didn't talk about your drinking habits, but I'm drinking also.
Yeah, and so he pulls some numbers out of, and he says it's log squared in the number of files in the project, which I don't believe, but it's something smaller than what Make does. So.
Yes, that I can believe. That makes sense to me.
Yeah. And so then there's also like two other things he has in the paper. So one is that renaming must be supported by the build system. And so you have to delete build outputs if they're no longer produced.
Oh, that was one of my pet peeves that I mentioned at Discord. I should mention again, but go ahead, finish. Then I want to tell you what the variation here is.
And so the idea is it's auto cleaning, or I think he called it auto pruning.
Yeah, right.
You don't use if it's a stale build result, it's deleted from the tree. It's not it's not there anymore. And then usability. So this is sort of like he wants a single build command that always works, because like if you read like Make guidelines and guidelines for other systems, they'll say, oh, well, if it doesn't work, then run Make clean. And so
right. Yeah. That's somebody's got the screwed up dependencies.
Clean.
Yeah.
And you should always type Make, and it should always work.
Yeah.
And so there's kind of a clarification that you can have sub-targets. And so sometimes you only want to build like a sub-target. Like if you're working on the JavaScript engine, you only want to build the JavaScript engine. You don't want to build the browser. And so there he's saying, that's like, so that ends up being a second form of pruning, is once you build this tree, you go down and you start from the target, and you say, I need this file and this file, but these I can ignore. And if there was a second target over here, you would just ignore that target.
Right.
And I didn't need it.
Oh, we lost Levo and all that. Fine.
Okay.
So I'm going to add a little bit here. And all my self-made build systems was always a thing that besides no output to stand it out, so no verbosity, your output build target was what you were saying it was going to be. And if you produced something else at the end of the build step, that was also an error, because I would routinely have cases in other build systems where somebody had a complicated build step and they built a temporary turd, let's call it a file turd, as part of that they accidentally depended on for the next go round. And when you did some sort of operation that was a normal build step, they would look at this file that wasn't included in the build system, sort of unintentionally discover that something stale was what they had, and they went with that. So I went to a zone where if you had extra files that you produced that weren't part of the listed things in the build step, originally I just nuked them, and then that was too egregious for other folks. So I complained and declared error. And if you went to run your build again, he would promptly say, this file in this directory is not in the build system list of things. I'm afraid that you might be using it accidentally. Nuke the file or fix your build rule. Right? And so people pretty quickly sorted out that they either did care or didn't care, whatever, and they would nuke the file or not. And there was a class of files that I read, like basically got git ignore, and said, I'm just going to ignore these. This is somebody's editor turds. There's your backup file for your editor or whatever. But if you had leftover manual builds and you produced a thing that wasn't part of the build setup, and I didn't understand the build system didn't understand what it was there for, but it was in the output directory, yeah, I'd declare error on you. Get rid of that file or declaim it part of your build step. And that removed a class of errors. So when you, hand in hand with that, as soon as you changed a build rule to the build output, the self-building build steps I had, the ones that would rebuild themselves, they would go to your old output directories and nuke them clean, and then they would finish rebuilding themselves, and the new build rule that came in would know about the old output directory, but it would have been nuked clean already. Fine.
Right. Well, that's sort of what these like Bazel, when it talks about hermeticity, that's sort of what they're ensuring, is that they literally run the command in a change root, and like they only copy the declared input files, and then they copy out only the declared output files.
Yeah, okay, right.
And
I think I did. When working with this in the make system, I definitely had rules where I would make a temp directory on the spot, CD down into it, do the build rule in the temp, copy the result back out, step out, and nuke the temp directory. And that prevented extra build turds from showing up. But you could have a complicated build rule that built a bunch of intermediate shit that you wanted to do all at once and had extra files as output because your tool produced extra files that no one cared about. Fine.
Yeah.
Rant. I'm done.
And so that's sort of what NixOS or Nix does, is it has these distributed builds, and so like, most people, they just use it for package management, but it turns out you can actually compile individual files in it, like a C project. So there's this experimental branch from like 10 years ago where the guy who made it showed that this worked. And so the only issue with it is it's incredibly slow, because you have to make a new temp directory, copy all the files in, and so on for every compilation invocation of GCC.
And I think that's what Maven and Gradle do as well. They create new temp directories, they copy everything in, and they actually so the sources actually have to get copied before they compile, not just the build.
So the difference is what level you do it at. If you do it at the project level, that's what normal Nix does. Is it, you build all the source files in a project in one go, but you do it in a new temp directory so it's clean. And that's sort of what Bazel does too, actually. And so what this experimental branch does is it does the isolation per file. And so that's why it's so slow, is because it has to copy every file multiple times for each time it's used.
I thought by default with Bazel that you kept all of the temporaries in a RAM drive.
Yeah. I mean, I haven't looked at how caching in Bazel works, but like it caches more than Nix is my impression. Nix just caches the outputs, and I think Bazel might cache some of the intermediate builds. All right, so this is the last one. This is called fabricate. So this is
this is fine.
Yeah, we were talking.
Sorry, go ahead.
Yeah, we were talking about automatic dependency stuff, and this just uses strace. So it logs all the calls to open, and then it you run the command, and it straces it, and it's even got parallel building. So like you see where it says run, so like all of these build commands run in parallel, and then because this is after equals lib, it waits until all the lib commands are done.
Oh, that's your dynamic dependency list using some sort of pattern matching.
Yeah, and so like
rules.
it's sort of a perennial thorn in like the side of like the Shake developer at least is like he's like, well, fabricate is so nice and clean, it does all this automatic dependency management and stuff, but like I don't trust it. How do I prove that it's correct? And so I was getting to the papers. This is the end of the slideshow. But there's a bunch of papers that have been published in like the last, I want to say 5 years. And they've basically taken like fabricate and shake and cup and so on, and they figured out how to get the best build system. So, I don't know. But I figured people would want to see what's out there first, because it's hard to have like a intelligent discussion if like you're saying, oh, I've never heard of fabricate,
Well, I'll say that this was a better presentation than I was hoping for or expecting, and so I apologize for not trusting you.
No, well done. Well done.
Yeah, of course.
So I have decided that anytime I need to research stuff, I'm going to turn it over to Allan. And anytime I need to name stuff, I'm going to turn it over to Simon.
How about Matt?
Wait, what happened to Matt?
Yeah.
He's our librarian.
Oh yes, librarian, yes, but the exhaustive review of stuff. Allan does a pretty good. He writes it up nice.
Good job. There you go.
I need a name for my IDE. Just saying.
Oh, you need a name. All right. Well, not my department now.
Yeah, and anytime I need something done in 3 days, I turn to Levo.
Levo, did you want to show an IDE? Are we ready to pivot here?
Yes, I am.
Okay.
By the way,
all right.
I just want to say something real quick. It's actually really quick. So this was based on a Reddit comment I left some time ago, but there was this guy on the programming languages Reddit looking for a replacement name for his language. I think it was called Charm, and he was looking for another word that was short, some kind of English word, a few letters, easy to remember, something like that. And like I responded, I actually think it's maybe a better idea to like think like pragmatically and think about just maybe picking a language that is, first of all, very searchable, so it doesn't have many collisions, and also something where you can register a domain and like other things like that. So honestly, Levo, if you need a name for your IDE, just smash your head on the keyboard and see what comes out. And I swear you're gonna have like great SEO. It's not gonna collide with anything. So yes.
On a side note, but you have to cross the threshold. If the name is not really known, the Google would mistake it for, you will believe that you mistake the name and suggest you a different name. So you have to gain some popularity first.
Right, yeah. But I think actually crossing this threshold is really easy. Like already when you have a like mediumly like popular GitHub repo or something, a few web pages, you will get there easily.
Yeah, maybe. Yeah.
Keyboard Smash. That's a good name
Keyboard
for an
Smash.
Yeah, I mean, actually, I was thinking a lot about language.
On that note, I have
like figuring out what name to like pick for it, and I landed on just going for acronyms. So I was trying out many acronyms, and at some point I was frustrated, and I actually literally just rage typed on my keyboard, and there were some really good things that were coming out there. So yeah.
Do you mind, Levo, if I interject one funny anecdote before you go?
Go for it.
So when I was trying to name the first company I started, Tangasol, could not find a name, and out of desperation into whatever the GoDaddy of the time was, probably register.com or something. I typed, I bet this fucking domain name is taken too, .com, and it was taken. And I gave up, and went downstairs, and that's when I came up with the name. But anyway, long story. Sorry, Levo.
That's hilarious. All right, I guess we're ready, but I'm just gonna take 1 second to talk about build systems. So I didn't talk about this the other week, and I know how Matt feels about build systems.
Or a hot button for so many people or anything.
I don't really want to talk much about it. I just want to show what I did. Now, this isn't meant for a build system for people. It's just meant for me. So
because you're not a people.
I do things differently. So
fair enough.
Not for our people. Not for our people.
Well, we've never seen Levo, so he could technically be ChatGPT.
Ooh.
Maybe.
Oh,
that's tough. Oh man.
So go ahead.
Turing test you, sir.
Well, anyway.
So that might pass.
I don't want to think about something witty. I just want to focus on what I actually want to say. So, anyway, I'm building a build system, mostly for me. It's also to get some ideas for maybe how I want to build with Bolin, but this is mostly for my C++ projects, like small tiny tests or an IDE, a build system, whatever. So anyway, the first column is always like a name. So you can see at the end over here, it says test. This means the IDE depends on test. And the test simply just builds a test CPP as a debug. My rules are pretty strict, and SIMD JSON will fail it. So what I did was, if you have dashes, you can pass in tags or options. And this says build and release because I don't want to step through it.
Wait, back up. So there's some built-in rule that takes a .cpp to a .o and a .o to an a.out or an exe.
Yeah, that's hidden behind the scenes. You don't have to think about
those are default baked-in rules. Fine.
Levo, do me a favor and explain what it is you're trying to accomplish with each of these decisions, because you tell us what the decision is, but you don't tell us what you were trying to accomplish behind it. So it'll make it everything.
Sure.
He's got a good name for his setup, though. It's make, except there's a Levo Lake. I think that's a good name.
Lake is always relaxing. Make is not. So the idea behind this is I typically just want to say build my tests as like coverage testing or optimize or just whatever. And by default, it will build in debug mode, but with sanitizers. If I don't want sanitizers, I say no san for no sanitization, and it recursively builds things. So if I am depending on a library, it will recursively build it with sanitizers, so it works throughout. But as I was saying earlier, SIMD JSON breaks some of my stricter rules. I have like a lot of like W errors. Because it breaks rules, I just pass in silent. So that basically ignores everything. So this is mostly for libraries.
Turns warnings as errors off.
Yeah, but just for this file.
But just for that file, yes.
Yeah.
So you handle subdirectories. What do you do with include files?
So the idea is if you include with quotes, it will recursively check it. So it would.
So one of your default baked-in rules is he can parse a C file, find pound include with quotes, and add that to his dependencies dynamically.
Yeah.
Okay.
So if the binary is built, it doesn't do anything, even if object files are missing. If any of the files that's part of the build is modified, then it will just delete the executable and then rebuild all the object files that has been touched.
So somewhere in its brains, it knows already that Lisp interop depends on main.h. Like well, it's the first time you run and you haven't seen interop, so he's going to build a .o. But now he's seeing that it depends on main.h. Somewhere you store that he depended on main.h, Yes, or you just reparse the file and you get
every
the
time
dependencies out of it.
Maybe I can open up my projects, but I don't want to stay too long on this. But the idea is every time you build, it will look at all the CPP files and check for the includes, and then recursively check it, because it has to look at all the timestamps. So I have to do it every time anyway.
Okay.
So once it knows that the headers has been touched and the files have not been touched and the object files make sense, then it will just link it. But as I said earlier, if object files are missing but the binary is there, as long as the headers and timestamps all match up, it will just not bother with building the object files, because the binary is done.
All right. And do you have generic build steps for things that are not C and C++?
Yeah, so here, or actually I don't have it here, but probably in my other projects, you can pass, if this isn't a build step, like if I did like thing.shell, it will assume it's an executable and just basically look if the execution bit is set, and if it is, it'll build it, but it does it every time. So you would want to do something like
okay,
let's just make a new line.
Like
Example
targets and make or whatever, they're going to build them every time.
So instead of this, I'm just going to put dashes so it's bad. You want to do test.output, and then you do this. So as long as test output has a timestamp, like an actual file, it's not going to execute the shell script. So if any of the files have been modified, actually,
wait, I missed. You're saying you have a default rule that if a dependency is a shell script and it's out of timestamp with the output, you will run it.
Actually, no, it's the rule. It's actually each rule will execute all its scripts every time, but since this has an output, it'll look at the file timestamp, and if that's missing, it'll say, "How do you build the file?" It will see this rule and then execute.
Okay, hang on. So let me try to understand here. On line 5, we demand a file called example, which we don't have. So we look at his dependencies, we check him. So then we go to line 6 to say test.output, how do I make you? And he does a normal stamp between test output and test sh, or he always runs test sh?
So this doesn't actually have to be an executable. It could just be like a header file.
Yeah,
so
test output is something else. So test sh is executable though. So it runs every time, which presumably I'm on line 6 still. Presumably that makes test.output.
Oops, clumsy with my fingers right now. So if you just think about it as a header, it'd probably make more sense. So if it doesn't exist, it will look up how to do the rule. And since the rule exists, it will just execute this. So it doesn't know what this does.
I'm saying,
it just knows this is the output.
I'm asking that the dependent file test.sh is also the rule. And he will then run the rule.
Oh yeah, that would just be illegal. I think it would just do the rule instead of the file.
Well, I'm asking, what would you like it to do? What is your goal?
For the build system.
Not for line 6 on the build system.
Yeah.
The goal here is that generated at h comes from test.sh somehow.
Yeah.
Okay. And then is that timestamp between those two, or test.sh always runs because it's an executable?
Oh, I see what you're asking. Okay, so it will not look at it. It will not look if it does not look at the timestamp of test.sh
because it's executable.
No, because the output exists here. So if I were to call this, if I say build generate.h, it will look at the timestamp.
Okay, so comment out line 5. Comment it out. However you comment out. Okay. Now into this build system, generated h depends on test sh.
Yeah.
Okay, and then I'm asking, is there a timestamp test, or do you always run test sh?
So since it's executable, it always runs.
Okay, fine. And then the presumption is it produces a generated.h. If there's a bug in test sh and he does not make a generated .h, do you stop then?
Yes.
Okay.
Well, it's kind of like I haven't like really tested it.
In your head, you would like it to now stop and say, basically, the rule I used to build generated H didn't work. I don't have one.
Yeah.
Okay. Now, if we go back to line 5, it says that example wants to come from generated H.
Yeah.
And example presumably doesn't exist as a file. So
only if it doesn't exist, it will look up the rule or execute the rule.
Yeah, because example doesn't exist, it will attempt. Now, that particular rule doesn't have an execution baked into it because generated.h doesn't have the execution bit. So he doesn't have a rule to build example, a recipe, a make, we call it a recipe, a build step to build the generated example from generated.h. So
line 6 is the rule or the.
Well, no, that line 6 builds generated.h. Line 5 builds example.
Oh, yeah, I see what you're saying.
Because he's trying to build example, what does he do when he's not given an execution strategy to build it? Like CPP is not fair. CPP has a default rule that says I can build a .o and a .exe called thing.o and thing.exe. Here, there's no rule at all. What would you like it to do?
Most likely error else, but I might have misunderstood what you're asking.
No, that's the question. So it's like in make, if we have these pseudo targets, then we do whatever rule is specified, including the empty rule, if you like build generated H, that's part of it, but there's nothing else to build example. And then we're just done. There was no error in any build step. We didn't get an example built, but that's okay. No one depends on this example file. It's just not made. I do this in my make when I run my tests. I have a rule that says anything that I can put that has some normal format, if I put a .exe on it, just like you have a dash release or dash silent flag, I change debugger.cpp to debugger.exe. I will then go look for a debugger.exe, which runs the tests for debugger or whatever, my test Lisp interop, runs the test sets, produces no output unless the test produced an output, or whatever output came out of the test, but I don't get a .exe. So every time I ask for a foo.exe, I run the test for foo. And that's my sleazy, cheesy.
Yeah, so that's part of the reason why I wanted the executables to run every time. But yeah, I'm gonna keep that in mind because I'm not sure what it actually does at the moment. But
okay, yeah, I was trying to figure out
maybe you shouldn't error every time. But
right now I see in this setup, which is kind of slick, you have this one line, there's a target on the left, there's steps on the right.
The reason why I like this the best is because I can say, just give me a release build, don't recursively build this as like sanitized or like coverage or whatever else. And I like saying, silence some of the files, but not all of my files.
You're doing a dash flag to change how a file is using the default build rule. You have a default build rule. CPP.
So with no dash, it will do recursive. I think I have it so if you do one dash, it just does the defaults, which is the bug. But yeah.
But what you say don't do recursive, like simd.json.cpp has his own dependencies because he has pound includes.
Yeah, I mean the general challenge, Levo, I don't know if you saw any of the stuff in the chat, like Chris asking about what happens if your files have dashes in them, for example. But the general challenge is that you have a bunch of implicit rules. So it's it's kind of like the only guy who can write Perl is Larry, because there's just too many rules, right? Like,
yeah. So that's why
when there's reasonable defaults, when you have 6,000 rules, it becomes very opaque to anyone who didn't write it.
See, that's kind of why I wanted to depend on shell scripts and executables so they can do part of the heavy lifting. And also, I'm trying to keep this as extremely simple as I can.
Yeah, actually, the relying on shell scripts is not that bad of a choice, because I mean they already do the imperative part of what you want to do, right?
Right. Make puts shell scripts in line. Basically, that's the rules on it. It's basically shell script in line.
Yeah, this doesn't care if it's a shell script. It will run Python like C executable. It's just as anything with the executable.
Emacs Lisp sucks. Thank you very much. It's a
Yeah.
full.
Okay. So can I go with IDE now? Because
Yeah, go. Yeah, you
that's what
went
I've
down
been
this
working
path.
on.
No one here steered you to that one.
All right. I don't remember what I showed before, but let's just.
Well, I didn't see multiple panes with tabs at the top before. Is this your IDE?
Oh yeah. Yeah, this is my
Here's
IDE.
your coloration. Yeah, I hate your color scheme. You're welcome.
Well, you can do. Whoops. This might be a little bit better.
Oh, I see. No, it's going to look like change how you comment. There's no comments, so I can't actually comment on your comments.
All right, so I'm just going to keep it light mode unless people.
No. I was giving you shit for no good reason. I am impressed with what I see so far. It looks really nice.
Yeah,
You've got a nice coloring editor. You can handle, I assume, giant files and your line numbers. You ever get matching? Let me show you a trick that Emacs does that you should do.
But I think he stole the font from Solaris.
What with Solaris?
I said, I think he stole the font from Solaris.
Oh, geez.
Oh yeah, it's some open.
Go down a few lines and find your parens, open, close things going on. I'm going to show you an Emacs hack that I use a lot that's really cool that other people should do. So just scroll down somewhere, find some parens. The line on the right, list interop on the right. Look at line 48.
48's all right.
Yeah, so you go to print, you got an open paren, you want it to blink the far end closed paren, the matching paren on either side. You'd love to have that. Okay, now go to line 55.
Just one sec. Oh,
okay.
Yeah, so I have a lot of certs, so if I do something get a little strange, it will complain and assert. So just gonna try this one more time. So I do have it colorized. So you can see this is purple, and yeah, this became not purple.
I'm sorry, I'm missing what you're doing here.
So if I
every curly is a different set of colors. They're just too pastel-y for me to spot.
Yeah, and it will affect the brackets as well.
I would take put an option in for more dramatic highlighting, but that's an interesting take. All right, clean that up, and then let's go to line now 57, buff.print. Clean up all your.
All Lisp code will look like a rainbow now.
I know, but maybe that's not bad. I don't know. So go on 55. Scroll in, put your cursor on the open curly. That's 54.
Haley's gonna love it.
Go down to 55. You still can't. You get hurt. Okay, go to the open curly. Click there. Okay, Emacs will have a separate matching bracket space inside string and single quotes. So I can find the matching place where I have dynamically put a matching close quote to that open quote. Oh, fruit salad. Yes, Theodore calls your color scheme fruit salad. I'm okay with that. And I find that very useful when I'm writing cogens, like you're writing JSON out, you're generating JSON as a text string. You need to have a closed curly to match the open curly somewhere. Emacs will highlight it for where you wrote it. And if you didn't, you'll eventually get a blinky spot if you go ask for the matching, and he'll tell you there ain't one. And that's very useful for having balanced quoting schemes in generated code.
So it does the balancing inside of the string?
Separately from outside, inside strings. I can show you in my Emacs if I rob from you the display. Go finish your show, and I can show you the Emacs matching balancing. It's a very cool hack, and it's very helpful for everywhere you do code generators by spewing out strings. Any sort of nested data structure that's coming out on the right-hand side as strings, do your thing.
So I'm just going to run this. This is test infinite. I'm currently running. I press a button. It shows me where it has the infinite loop. I can look at the call stack. It gives me data. Actually, I think this is just this is what GDB runs. So it has nothing to do with my code.
Oh, you think that's just not wrapping? You know, in a modern processor, 4 billion will wrap in a few seconds.
Yeah.
So that could be just a wrapped number.
I think it's just dirty data from the stack. Anyway, this is my crash test. So I'm going to show you the launch actually. So
now can you debug your IDE using your IDE?
That's I'm working up to that. working on it.
I
So
totally did a kernel debugger where I had to debug my debugger using my kernel debugger because it was in the kernel, and that was painful and interesting, exciting, painful, however you want to call it.
Anyways, this is my launch. So this is just basically saying all these labels follow the same rules, and it's just Lake and then the label. So it's debug GCC.
I'm sorry, what is launch?
Launch. Okay, so when I press F5 to launch my debugger, these are the rules that it follows to know how to launch it.
So your IDE has some go launch a debugger, but do the following things like IntelliJ. I do a make or a build before I launch the debugger, and it's like stupid because Turbo Pascal 40 years ago had all this baked in. It was so much nicer. Fine.
So pressing F5 will do the launch, which is the build and then debug.
Yeah.
The build step is just calling Lake with the name, and the name comes from these.
Yeah.
So whatever I have, like you can see all of them here.
Yeah, just go do a launch.
Yeah.
Oh, you're showing how you have a strategy which says I'm gonna describe an IDE. Yeah, okay, fine.
Yeah, this is drop down, and like test infinites, that's not part of this one. It's part of this one, because I want to pass in an argument, so I can't follow this rule because I don't have an argument in this rule.
Okay.
So it's really simple. This is saying change the directory to whatever the IDE is running in. It just says go into the build folder of that directory, and then execute the program with bin. Instead of giving it an explicit name, I have my build pass in the generated name, because depending on the rule, it will just generate different executables. Because like sanitizer and nosan, you don't want to mix them. So even though they're both debug, it's a bad idea to mix them. So it's a saying. The build, actually I should show this. I'm just gonna open this up. So I'll just do, this is, I haven't built this for a while, so I don't know if this is actually going to work. But anyways, you can see how this is dash clang. All right, it worked. Dash release, and this is no sanitization.
Yeah.
So I don't mix the binaries. It just makes things easy.
Oh yeah.
Yeah. So so since I don't know since I don't want to think about the tags, I just have my build system return me the binary through a file descriptor. It'll just write to the file descriptor, and then I just use that to figure it out.
Imply a file called test that you then use in test crash. It's fine.
All right, so let's go back to my IDE. This is the build I usually test with, so I know it mostly works. I'm just going to run this. This is my return 4 test, which exit with 4. If I run it multiple times, you can see the process ID changes. So I'm just going to go down here. Actually, wrong one. Oh yeah, fuzzy find. So I just type in, if I type in map, it'll show me a key map. This shows up because I have like a really simple algorithm. VS Code, I think, does the same thing. It looks for the first letter, then it just iterates through it and tries to find out if every letter is ahead of what you wrote.
I'm sorry, you just said fuzzy find? This is
it's
things sort of like.
Yeah, it's not like fuzzy finder, or people when they say fuzzy find, they have something better than this, but this just looks where the M is, then looks if there's an A afterwards, and then looks if there's a P afterwards. And since CPP has a P in it, this matches.
Oh, you have an M, A, blah, 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 P. Yeah. Right. And key map in the middle, sure. Okay, you look for map, anything contains the letters MAP in a row.
Yeah.
Yeah, fine. But I didn't understand you're doing a search. It went by very quickly in your description of what you were doing.
Yeah, so
not necessarily in a row. And actually, I think it's handy because you have long names like, I don't know, abstract factory, blah, blah, blah. You put AFB and it gives you the file. So I find it handy, and I think it is intentional for this kind of use cases.
Okay.
if
use abbreviations.
Emacs, you use like file finding on the shell script. You hit tab to complete the partial. AB tab, it says abstract, and then there are 17 more choices, and you hit F or file or whatever it's going to be, and tab again.
So there's step in, step out, or
there's a debug build.
Yep.
Yeah, fine.
Step over, step in, all that good stuff.
Yeah, I've not tried to debug a broken IDE per se. I guess when my kernel GDB was, my kernel debugger was, but interesting.
I'm just gonna.
It's pretty awesome.
Yeah, it is. Yes.
Yeah. So
it only took you 3 days.
Yeah. Well, the GUI itself took more than 3 days, but the rest of it definitely 3 days.
I'm giving you shit. This is very impressive work, sir.
Yeah. I'm not done though. So
we better step it up then, because we're gonna have to move on at some point.
Okay. So
stop encouraging him.
I'm sure some of you will say yes, but can your IDE do this? Or I think I pressed the wrong button.
I can press the wrong button in my IDE. Yeah.
Yeah. So, because I don't have like buttons for everything yet, and it's very easy to press the wrong thing. So, okay, what's supposed to happen is. Oh yeah, I forgot to hit run afterwards. So I'm just gonna redo this. Like this is I literally implemented this this morning, so that's why I'm get choked up and confused. So if I highlight this, I don't have like I can't type it in the watch at the moment, but if I highlight it and press the F8, it adds it to a watch. So my question was, does your debugger have a watch points? Because right when G1 is written to, it's going to break. And it doesn't on the line afterwards because that's what GDB returns to me. But you can see that it returned to me the old value and the new value as well.
Oh, it's catching you before it actually does the write. You're watching on G1. Okay.
Oh yeah,
I know
yeah,
that's claims to be in IntelliJ, but I don't use it very much because I don't believe it.
So this is another feature I completely forgot to talk about. So you see how there's G1 twice?
Yeah.
If I go back up here, G1 disappears, even though it's global. Why is that? Because I have, what do they call that? Oh, simply just watch. So this is one of the things I really wanted to implement in my in the IDE. So I say a specific function, and whenever the debugger enters these functions, it'll add these to the watch variables. So only in var test it will add this, but I want it as like plain decimal and hex. So that's why I have 2 of it.
Yeah.
So
gotcha.
I don't know why this is not launching.
So every time you call var test, you stop, talk to the debugger. The execution strategy somehow breaks into the debugger, adds a watch, and whenever you leave var test, you break into the debugger and remove the watch.
So for whatever reason, it's not executing. So that's one of the reasons why I am annoyed with Visual Studio, because it will not execute. Just for
this is
reason.
all about how to do live demos.
Yeah.
Things just break because they do.
That happens to me like almost every day. So it's just not because it's live.
But
yeah,
have some debugging yet to do.
Yeah. It also highlights in red when things change.
Yeah. Okay.
Yeah.
I mean, IntelliJ does this, so and it's all fine, but it's all very cool as well.
IntelliJ probably has 33 people working on it.
Oh, it has a huge count, and it has an enormously busy interface, and I would drop 90% of the things that IntelliJ throws on the screen at you.
Yeah.
And to get a much simpler, layout of things.
So there's one other thing I want to show. I don't know if this is going to work, but got to restart for sure. Test. So let's go here. So yeah, you can see everything works. And now I'm going backwards.
Ooh, how far can you go backwards?
Well, it's not actually my code.
Oh, it's not actually.
Well, I implemented. So what I'm using is there's something called the undo debugger. It's a time traveling debugger.
Right.
So
you've changed debuggers. You're not using GDB, you're using somebody else's debugger, which means you can flip debuggers. That's already interesting. And then that debugger supports an undo.
Yeah. See, I don't have any visualizations to see if I actually switched. So I've just got to press the button and hope it picked it up.
Right.
I'm not sure why sometimes it doesn't pick it up. It might just be my keyboard.
Yep.
But anyway, yeah, this actually, this reversed to the end of this.
Test.
Yeah, so this is like going through, that went to the constructor and now it's going through this. This step in, step back out. I know it's hectic to look at.
But
there's also
very
cool. Also a
cool.
reverse continue, and that didn't work for whatever reason. It's probably because I didn't parse this correctly. I'm not sure why.
See Matt's note in the chat, GDB's reverse execution stuff.
Oh no, GDB has this now? Well, this has to go in a link in the docs.
Anyway, yeah, Levo, my suggestion to you is before you do the demo, make like a list of 5 things you want to get across, and then that way you can like kind of
focus.
This is CCC. We're supposed to nerd it out.
No. You're getting across. I can interact with a backwards running GCC. I'm getting across. I can highlight bouncy quotes or strings or curlies or whatever. Yeah. You're getting across. I can flip between different files. I can run the debugger. Those are the things you're trying to get across. And then you can focus your discussion a little better about that. So that's a totally fair.
Okay. So this is the last thing I want to show. Right now I have, so earlier I showed how there's a watch point where you can, the debugger will stop when the variable is written. But the thing I implemented just now, like when CCC started, is doing it backwards. So it's a little finicky.
So you're highlighting G1.
Oh, wait, you know what? I think I didn't switch the debugger, and that's probably why it's not going. So I'm going to go here. I think, yeah, so I just implemented, so I guess I broke something. But it was working earlier. I'm not sure what I did to break it because I didn't really change any code.
It's always the case as you do these things, and 10 more minutes after CCC winds down, you'll have it fixed. Save it for next week.
Yeah, but yeah, that's about it.
That's pretty cool.
Yeah, I'm just gonna try my luck one more time while you guys decide what else to talk about. Let's see if it works.
Because it'll work the second time round, third time round.
Maybe third. Oh, hey, there it is.
What did it do? Oh, going backwards, you watched in reverse.
Yeah, so I had that breakpoint at the very end of the program. I did a reverse like watch point. Right. So it went to the last time the thing was edited. And there's a VS Code plugin. I guess I'll just have to turn this off. But there's a VS Code plugin. I'm just going to launch it right now. So you see how there's like a bunch of things up here?
Yeah.
Yeah. So this one, so whenever I have a problem and I want to know why a certain variable has a certain value, I could just press this button, last changed, type out the variable, and then it would jump to the last to where it was last modified.
Yeah.
So it's so handy. Like this is my favorite feature, hands down. So stepping upwards, that's pretty cool. But last right, I have no idea how they implemented, but it works so well.
Well, they had to track all right. So I'd be interested to how well that scales on very large setups.
Yeah.
Very large programs. That would be very cool. That would be a thing that I would happy to use, but I'm using Java, not C, so I don't know how they're gonna track the last this and that.
Yeah, I have no idea how good the Visual Studio debug adapter protocol. Yeah, I forget what it's called, but yeah, I have no idea the quality of that. But I went straight to GDC because I didn't want to miss any features. I don't know what the LSPs and DAP has. That's about it.
I think we're going to wind down. So somebody want to say something else, or we can just be. This is a high quality CCC, so I think we can end on a good note here.
Well, I just want to do 2 things. So one is that like I looked up on DoDB, and it's like I don't know, it's like $100 or something. They definitely aren't open source or anything like that. And then I wanted to mention that a lot of the papers in my slides were linked from like Matt's list of links, which is I put it in the Google Doc. So.
Cool. And then Adrian?
I was gonna say you did mention Turbo Pascal like a half an hour ago.
Yeah.
And then I realized I saw that today is actually the 40th anniversary of Turbo Pascal.
Huh.
So that's pretty cool. Feels like
hey, that means I'm almost 40 years old.
Right. I was one of my fun, early, easy, learn how to code, learn how to do stuff.
I mean, yeah, like Turbo Pascal is one of the reasons I'm actually pivoted my compiler to single pass design. I was bickering on Hacker News with someone about this. Like, it's actually interesting. I think many people are really have very negative like association with single pass compilers. But I mean, the thing is, like, there are so many things I noticed. Like, first of all, the code architecture is very, very different. And the way you just do things is also like super different. Like, it's just such a different design, and figuring out how to do like how to support multiple backends in a zero cost way, like, and still make the code composable is a bit like it gets very much like very quickly like spaghetti a bit, at least the way I did it currently. But there's some cool things like, since you require everything to be declared in order, you can, like, inlining becomes a mem copy. You just need to strip the like epilogue, the prologue, and then you patch some of the registers and stuff like that. I don't know, like things can be done in a very cache efficient way as well. I feel like this is, I think it's actually really beautiful in some ways. And the thing is, I mean, first of all, since Turbo Pascal got created, I mean, our CPUs have changed, so some things there, but also our compilers got better. So, I mean, I guess the guy who is working most on Turbo Pascal, he wrote most of it, almost all of it, in assembly, if I remember correctly.
Oh,
so
okay.
Like
Lexer,
parser, code generation, everything. So yeah. But nowadays you don't have to do that, at least for large portions of the code. You just throw LLVM at it, and it's gonna be quite fine.
Those Anders, right?
Yes, right. Anders.
The thing about assembly is I hate writing short circuit logic in it, and I use a lot of it in my C++, and it's just such a pain to write.
The compiler exists for a reason. Yes. That's interesting. No, I didn't know the internals of Turbo Pascal. For me, it was just it was an IDE where the edit, compile, debug, turnaround cycle was super tight without needing mouse clicky things or whatever. I typed code, I hit an F button, it compiled, no errors, so then it ran. I didn't have to do anything else, and then it was running. And then if it hit something, there was some debug strategy, which I don't remember, followed by I would go edit my code and hit the go button again, and it was just super nice. And then, IntelliJ, there are several buttons I have to press to get him to compile and debug, depending on which strategy he takes, or whether he decides he's going to error this time or not. He doesn't always launch and go when I say do it. He has window focus things so that I've clicked in the window. I want to set a breakpoint. The first click didn't count because he had a focus change. And then the second click actually sets the breakpoint, except he decides that I wiggled the mouse too much, so it was off the place you put a breakpoint. So 4 clicks later, plus a very fine-grained, strategy, I got my breakpoint set. It's like, oh, come on, fucking asshole. Never mind. I'm like so annoyed at IntelliJ interface, no matter what I do with it. But now I'm whining. Stop. I'm stopping whining. All right. This is a good one. I'm going to claim victory for the Alliance and walk away. And until we meet again.
All right. See y'all.
All right.